Hi guys, welcome back to another video. I hope you're all doing really well. Today I've got some really exciting news to announce. So as of this video uploading, the DIY CNC project has officially launched over on my website. I've released this as open source and all the files are available to you for free. There's no paywall, no email wall, anything like that. They're just available on my website for download. So before I get started in this video going through everything, please just give the video a thumbs up straight away and share it. One of the things I really want to do is get this out there and get it in the hands of as many people as possible. I'd love to see this being built all around the world, similar to my prior project Raptor 2, which I've seen many builds, and it's just such a great feeling when something I designed is existing somewhere else in someone's workshop. It's just really cool. Also, if you really do appreciate my efforts here, please consider donating on the website. I have ultimately decided to release this for free, and I could have easily charged for these files and made thousands from that. There's a lot of interest in this machine. However, I decided not to do that. So if you can contribute, however big or small, please do so. I'd really appreciate it. And it's only an investment that will go into future projects and other videos. Everything here was paid for through my YouTube channel by people watching my videos and showing their support. And I'm hoping that whatever comes through this project, I can turn into another project. And maybe you can replicate that as well. So thank you for your patience in waiting for the files. The reason I took so long to actually upload them and make them available is because I just wanted to be really confident in what I was handing over here. So I've now racked up hundreds and hundreds of hours on this machine. I've run jobs that are over 18 hours in length, and there's been no issues. It just smashes it. It just churns out everything I throw at it. I've used a wide range of materials in terms of wood at the moment, from pine right up to oak, ash, beech, lots of different hardwoods. And it's able to machine those fast at just, like 12,000 RPM. And I'm very shortly going to be moving on to aluminium. As you can see here, I've actually hooked up an air hose. I have a pump underneath here as well. And I'm going to be diving into that very soon. So this project is kind of still in development. I'll still be testing it, releasing videos. But you can now get hold of all the files if you want them. The files will include technical drawings, all the 3D printed parts, bill of materials, the original Fusion 360 CAD file, along with a bunch of other formats as well. And I'll run through what's available on the computer very shortly. In terms of reflection on the project, I think sometimes I look at this and I still kind of kick myself a bit in that I built this thing right from scratch. I designed it on the machine and manufactured it here in my little shed with a pillar drill and a couple of tools, and now I'm able to create so many cool things. And that was the whole idea behind this project, right? Like I said, I could have charged for the files, but that would have gone against the whole reason I did this in the first place. That reason being, I don't have a huge lump sum of money that I can splash on an industrial type machine, and with the budget I had coming in at around £3,000, if I had spent that on off-the-shelf machine, what I would have had would be a lot less capable than this here. There's some other brands out there that are, they're good machines. I'm not slating the machines at all, but they're not capable of what this is capable of. And in buying a machine, you don't get to do all the learning. You don't understand fully how things work. I know every centimetre of this machine because I built it. I think there's a lot more value in that than just having one off the shelf, with also obviously saving a lot of money. My goal with this has always been to help other people in a similar situation. I know there's a lot of people out there, whether you're fairly young like me or just retiring, you want to start up your own workshop and you just want to make cool stuff, not necessarily as a business or to make money, just to explore as a hobby, and I wanted to make that available for as low cost as possible. So that's exactly what this does. The total price came in just under £2,700 at the time that I built it. It may have gone up or even down since. Inflation's all over the place at the moment, obviously, but you might even be able to find some of these parts on sale, which I wasn't able to do. The interesting thing is, even if I wanted to now, I could make another machine on here and manufacture the parts out of aluminium, for example, or maybe even mild steel, because I now have a machine big enough and capable to do that. So once you've got your first machine, you're kind of through the door, because you can then use that to manufacture other parts. Remember as well, what's cool about the way I've designed this is you can make modifications to this without having to necessarily modify the CAD files. For example, the gantry there, this back plate, is 800 millimeters in length. So if you want to have a machine that's 1,000 millimeters in length, the only thing you'll have to change is the length of the back plate, the length of the linear rails, and the length of the X-axis ball screw. And that's a modification. So you'll have the same machine, just wider. Same goes for the Y-axis. My Y-axis is 1,200 millimeters. If you want it to be 1,500 millimeters, same thing. You just change the length of your runners, probably add an extra cross section or two, change the length of the linear rails and the length of the Y-axis ball screw. So you can completely modify it in X, Y and Z just by changing those simple things. You know, you're going to have to add the extra holes to bolt the rails down and all that stuff. But the core of it is done, you know, we know it all lines up. So if you want to change the width and length, that's up to you, and you can do that. And again, that's kind of what I wanted to do from the start, was make it easily customizable, even if you don't understand CAD. And I think I've achieved that. So what I'll do now is I'll move the camera forward a bit here and I'll show you some of the larger 3D reliefs I've done on this machine in the past couple of weeks. And then I'll jump over to the PC, I'll run you through some of the files that I've put available, just so you understand what you're getting and what to expect in the future in terms of future releases and updates and that kind of thing. Okay, so like I said, I'll show you a couple of the large pieces I've worked on here. So this was a piece of beechwood, and this is obviously the Leonardo da Vinci, The Last Supper. Pretty big file. The model wasn't particularly detailed, so it could have been more detailed, but this was the first one I tried at this scale. Started as a slab of beech, as I said, and I was able to turn it into this lovely piece which I've stained with some Danish oil. I think you'd agree that looks pretty good. And also I have another one here. Which is my favourite so far. This is oak. This started as a slab of oak, and this is a scene here of sort of an aquatic setting with a turtle on the front here. And this design had the frame inside it as well. No finishing on that, apart from some sanding on the edges, done with a ball nose bit, 1.5 millimeter, and the result is just incredible. Again, you know, it did this in about 9 or 10 hours at that detail, which is quite impressive, and it completed the job, no hiccups, no issues, absolutely brilliant. I've also worked on a lot of smaller pieces which I've showed you in the past, but going forward I'm doing a lot more stuff like this, and you can turn these into products, you know, like this one. I've got hooks on the back here so it can be wall hung, or you can put a bit of string on there. It's brilliant. This machine can make you a lot of money if you invest the time into it. Okay guys, so what I wanted to do here was just run you through how you can obtain the files and briefly what to expect within the files and sort of going forward in the future, that kind of thing. So on my website, there'll be a link to it in the description below, but you can go to thehardwareguy.co.uk. Under projects here, you'll see DIY CNC machine, which will take you to this page. On here, I've given a brief description of the project, the machine specification as I've designed it, and there's a little gallery down here which showcases different stages throughout the build. You can see there the example I showed you on the bench before it was stained, and a bunch of other different photos. Underneath that, we've got the section that covers open source. So like I've explained earlier on, this is up here for free. There's a donate button here if you're willing to contribute and you really appreciate the work that I've put in here. It would be massively appreciated. You can just click on that, you will donate via PayPal, it'll ask you for an amount. Or alternatively, you can become a member of my website, which will enable you to contribute every month, and in return you get access to my Fusion 360 course, CAD files, 3D models, all that good stuff. But you don't have to do that, you can make a one-off donation here if you like. The total cost of the machine, £2,655.80. That is to the penny of what I paid during the time of my build. Like I said, it might go up, it might go down, plus or minus 10% I'd say. But if you time it right, you can pick up things on sale and save probably even more. You can download the files by clicking the big red download button. It'll just save a zip to your machine, and that's it. There's no sign up, there's nothing. They're just available. Inside, I'll run through these in a sec in the actual folder structure, but you can see what I'm putting up at the moment. I may add to this if people want extra stuff. Just let me know, and the best way you can let me know is by joining the community Discord server, which is a link to here as well. So if you click that, it'll take you to a Discord portal. Whether you're signed up or not, basically Discord is just a space where people can create a server around specific topics, and it's a great place for building little communities where people can chat to one another. It's essentially like a giant chat room with different topics, and I highly recommend coming in there and checking it out. Below that, we've got the release notes. If I click on that, this page is where I'll track the changes to the project. So I've got the release here as the 20th of July, which is technically yesterday, but that's the time I created the page. And as things change and as things are ongoing, I will update this release note here. It's important to understand that this is a big project. There may be some small teething issues. People might find issues that I need to fix, which I'm more than happy to do. And like I said, the best way you can give me feedback is in the Discord community. So if you're stuck, if you're unsure, or if you have found an issue, please report it in the Discord community and I will address it. Going back to the project page up here, we can see that underneath this we've got the video series as well. So you guys know these are all hosted on YouTube anyway, but I've got a video collection here on my website where you can just play any of the videos. All of them are in there. If you click on load more, there's 15 in there at the moment, and I will be adding this video at the bottom as well. And that's basically it. If you want to stay updated on anything that I'm doing, sign up to my email list. I do not spam. I just like to collect members on my website so that if I've got a big project coming up or if I need help with something, I can push those emails out to you. Also, occasionally I give stuff away, and you might as well be in the loop with that stuff. So there we go. That's basically how you get the files. Just come down here, hit the download button, and you're good to go. Now, inside the zip file, you'll find this. So before you do anything here or use any of these files, please read this document. It's very important. I'll open it up for you now. Basically, I've explained the project, that it's open source, and that I've ultimately created this for educational purposes and for people who are looking to get into CNC and learn a new skill or new hobby. I've put all this in here for you to have a read through. I've contained all the different video links in there as well. I've explained that it's an open source license, and my only restriction with this is that the files cannot be sold. I've given these away for free, so whatever you do with them is on you. You can modify them, you can redistribute them, you cannot sell them, and if I find people selling them, I will take action against that, because this is an open source project and I want it to stay that way. Underneath there's a big disclaimer, and this is really important. I mentioned this in the videos when I was going through. There's no liability on my part for anything that you do with these files. By using them, modifying them, building anything, it's on you. And that's a big thing I explained in the videos, particularly around electrical and electronic parts of the project. Now, I'm in the UK. I understand the electrical wiring in the UK. I'm quite confident doing that. That being said, I'm not a qualified electrician, and it's important that when you do your electronics that you seek an electrician and get it certified, particularly if you're running this in a business or you have home insurance, that type of stuff, because anything that isn't approved can void a policy, for example. So it's really important that you go down that route, have everything done properly, and just make sure it's safe for your benefit, for your family's benefit, and you'll just be better for it. There's another thing I want to cover here, which is operator safety. Again, like it says here, CNC machines are dangerous. They've killed people in the past and they'll kill more people in the future. I think people do underestimate the strength of some of these machines. This one is very strong. If your hand was anywhere near the parts when it's sort of at its homing point, it definitely break bones. So do be careful. You know, you need to understand the dangers, how to stop the machines, how to use the software. That's all stuff you should take very seriously and make sure you're educated before taking any unnecessary risks. I've provided some links here for UK electrical safety. You can find qualified electricians through these links. There's regulations that you have to follow, and I've said here, you know, it's based in the United Kingdom. I can't recommend or make any comment on anything outside of the UK. I just can't do that. I've no experience with it, and that's on you to make sure that's done correctly. I've also included some links for operator safety training as well. Like I just explained, it's important you understand emergency procedures, hazards, maintenance, which is a big one, and just operation of the software. There's links here where you can undertake training. Again, I have no affiliation with any of these. They're just things that I found online that seem to be very useful. So please make sure you have a read through this. I know it's not the most exciting thing to do, but it's serious and it's important. So do read it, and I'll have it on my website here as well. And basically, by downloading the files, you agree that you'll read the document and understand the contents of it and take full responsibility for the machine and your build. I've separated everything out as best I possibly can here. We've got 3D printed parts, which contains all the 3D printed parts for this project. It's pretty evident what these are. I've tried to name them accordingly, but they're in there as STL, so you can get to printing those right away if you want. There's a CAD folder. Now, I've tried to export in as many formats as I can. The original is in here, Autodesk Fusion 360, and if you open that, you will see the project as I saw it when it was designed. That is a complete archive of everything. It'll all be in there. I've also exported for Autodesk Inventor for anybody that may be interested in that. I don't use that personally, but they're the same company, so some people like to use Inventor instead. There's an empty folder in there which I'll get rid of. I've also got OBJ here. There's Step and STL. Generally you can't really modify those very much, but I threw them in anyway in case you wanted them in there. Whether that's for display, or you could even 3D print a mini version of it if you really wanted to, which would be pretty cool. Mach 3, so in here I've included the driver for the Mach 3 breakout board and also the configuration file. So a lot of people ask about this. I did post this in the Discord recently. If you remember, when I was going through the videos, I had set up Mach 3 to work with the Mach 3 breakout board and my pin configurations for the motors, the sensors, all that stuff. What I've done here is given you the profile, so if you launch Mach 3, load in my profile, you'll see Mach 3 exactly how I see it when I'm operating the machine. So that'll just save you setting it up, but make sure you double check everything. Don't trust that your wiring matches what I've got here. You may have done something different. So just make sure you understand what you're changing in there. Parts and cost. Most of you have seen this before. I'll open this up just to show you, but basically it's a full bill of materials for all the different areas of the project. I'll pull this over here. So I've split it up. We've got machine hardware, frame materials, bolts, stand and control box, and that's the total cost. So the stand obviously was just timber, 3x2. I've got all the different lengths there, the quantities and the cost from me locally. Again, you may get this cheaper than what I was able to here where I live. The machine hardware, this is the things like linear rails, ball screws, spindle, all that stuff is in there, with links as well to all the different suppliers. Bolts, all the bolts you'll need for the project with a couple of spares. Everything should be here, and you can order these through Bolt World if you want. This isn't an affiliate link or anything like that. That's just the supplier I used, and they were really good actually. Quick delivery, quality bolts, and that was just my choice. Again, you may want to use something different, and that's fine. The control box, this is everything for the electronics, including the enclosure, the fans, all the hardware that you saw, the cable. I've even included some of the corrugated conduit that I used. Again, many of the supplies here are for the UK, so if you're outside of the UK you might not have some of these suppliers, so you'll have to find equivalents elsewhere. I've just found what I could for where I live. And then obviously the frame materials. Now this one's important because you'll notice it has drawing references in here. So I've created all the different parts, the dimensions you'll need to order, the quantity and the cost for me. Again, they might change a little bit for you. So pay close attention to the drawing references here because it's relevant in the next section, which is technical drawings. Now in here I've included again all the drawings in different formats for you to use. So if we look at 001, which was the y-axis cross sections, you can see I've got in there PDF, DWG and DXF. Let's take a look at something a bit more complicated just for example. So let's look at the Y motor bracket. If I double click this, the PDF will open here, and if I zoom out you can see you've got the full technical drawing with all the measurements if you wanted to create this by hand like I did. Again, remember, drawing reference number at the bottom correlates to the part in here, so just be aware of that. You can see it at the bottom there, 005 is the Y motor mount, which is exactly what this is. Just for demonstration purposes, let's look at another. So we've got the motor back plate. Let's have a look at that one. There we go. This one's a little bit more complicated, but all the measurements are in there. You can see exactly what you're getting. Reference number 011, which correlates in here, Z motor plate. So I've made it as easy as I can for you to understand what all these things are and the reference to the parts. So hopefully that is of use to you. Another thing I included was the plans for the spoil board and the baseboard. So there we go, I've opened Fusion there. So you can see here what I've included is just a little breakup of an 8-foot by 4-foot MDF board, which was 18mm thick. And out of that single board, I had the baseboard for the machine and 3 spoil boards. So that works out perfectly. You only have to buy one big board. You can cut it, ask them to cut it up for you nicely, or if you can do it yourself, even better. And you have very minimal waste there then when you go to actually install those. You can use the cut-offs to practice on, doing your first cuts. It's always useful, but I thought this would benefit you guys as well, so I've included that too. There's another folder here called resources, which I've included sort of what we went through in the videos, calculating your steps per millimeter, the closed loop specs, and determining a power supply value for your setup. There's also a wiring CSV in there which contains all the values and colors for the quick disconnect connectors for the steppers that I'm using. Again, if you're using different steppers, yours might be different. Just be aware of that. So there we go, that's super exciting. This will be going live later today along with the YouTube video that you're currently watching, and you should be able to get access to these very soon. So there we go guys, thank you so much for watching. Thank you for following along and supporting this project. I decided to share this just out of interest and to document my own projects as I always do, but I've been really excited to see the interest in this that's been picking up on the channel, and it's been evident in the analytics as well. I've released this for free, provided you've got the funds for the materials and the skills to build it. There's nothing stopping you at this point. You may even want to make a few changes. You might use a different spindle. You might even build yours out of steel. The parts are always going to look the same. The files are always going to be the same. So you can build it out of whatever material you want. And that's even more exciting. I think some people probably will choose steel or mild steel. Just bear in mind that steel is much heavier than aluminium. So if you go down the steel route, you might want a more sturdy base, or just make sure your floor can support it. I'm in a shed here with a wooden floor which has got OSB plywood on top of it, and I made sure when I built the shed that the floor is really stable. Ultimately, that's the beauty of building something yourself. You have complete control over what you do. You can make it yours. I can upgrade this in the future, I can change it, I can completely change the electronics because I understand it and I know how it works. So there we go guys, as always, thank you so much for watching, thank you for supporting the channel, and if you do appreciate this work, please do consider donating and supporting me in that way. If you can't do that, at least give the video a big thumbs up and be sure to share it wherever you can. Like I said, I want this to reach as many people as possible. So thank you, have a lovely day. As always, I hope you learned something, and I'll see you in the next video.